All right. So yeah. First of all, last time we just kind of like tested like some end-to-end or like kind of policy to vector test. Like we just kind of basically tested like we're kind of like trying to test like the full circuit, like testing policy to vector and vector to policy, like so yeah, we did that last time, and then all I did off stream was I just yeah, I just did git push, and well, I pushed it. So basically, that's basically it. Like we're basically, I feel on the verge of actually like starting training. Oh yeah, there's one more thing to do. Let's just do that actually. So one thing I was like kind of, I was looking at game state, and I was looking at the refresh function, right? And I realized that like it was only like it wasn't really used, like I didn't see a use. So I kind of realized that like I was like kind of like it's like to be done immediately after physics update, right? So one thing I realized that like I completely forgot to do was in apply move, and this was like maybe like a week ago or a while ago, is that after we do physics to update game state, sorry about that, we have to do this dot refresh, right? Like if you look back at the comment, like to be done immediately after physics update. So like in a sense, like I already talked about my distaste. I feel like this stuff should be done inside the physics function. But anyways, oh well, whatever. It's just the legacy code from like a long time ago, like 2020, 2019. Pretty old. But yeah, I think that's it now. We just like do this dot refresh. Status. Clear, get diff. Let's make sure it runs. Okay, good. And that indirectly tests this one too. And for good measure, let's just do train.ts also, which is like the top level one. Okay, great, because like we have to do node train.js or like TS, well, some caffeinate thing too for long running processes. But yeah, I think this is it. Let's just quickly do a git add. Status, git commit, fix not deleting coins at 0 health. Status. Okay, great. So I think we're basically actually ready to go. Now, if we take a step back, right? Like what I wanted to do this stream and what I called this stream title was review basically like review prior work, right? Because like on bots, I think that's top. But anyways, like the point is that like a few years ago, I decided, you know what BumperCoins really needs, like which would be super cool for BumperCoins to have? Bots. Because like a lot of like people like kind of like it's kind of hard to grow a game or even like have a game, like have an active player, I mean have a player base without like bots, like which takes us back to the beginning, right? Like if you want to play BumperCoins, then and like you just go on and you find no one in the pool, like no one to play with, then you're just gonna leave, right? So like you could invite a friend, but like that's kind of why I guess a bot to play against would be a good idea. And also because it's like a finishing touch too. So anyways, so like I did work on some bots, like this was like what, like 2020, like a while ago. In fact, let's have a look. And then like basically like okay, so like I was using my master branch, and then like I eventually like I was having a bad time, like I wasn't really achieving anything with the bots. So I basically like kind of put it on the back burner. Like I just kind of like stopped working on it, or other things came up too. I just stopped working on the game in general. But like but yeah, I did do some work. And actually that's kind of why like I was kind of familiar with TensorFlow even before like currently I'm on like I guess like the past few months, like kind of like doing connect for and BumperCoins, and like I've kind of like been going, well, not, I cannot say going fast, because I mean all this work should have been done in like a week or two, and it is stretched out. But like in terms of like kind of like to a viewer, or like to even like me, like kind of like looking at like TensorFlow, it's like I feel like I'm kind of skipping past things like transposition and stuff, and like NHWC, like for like CNNs or whatever, like the number, the height, the width, the channels or whatever like those formats are. Because actually like these kind of like transposition, like some of this like problem I've actually already encountered like a few years ago when I tried to like work in bots. So it's not like I'm kind of like, I mean, I started off fresh, but like I do have some prior work. So I guess like, yeah, so the thing is to review it. Now the reasons like why, right? Like if you take a step back, right? Like what are we doing in this train.ts file, right? Like in our like basically like we have train.ts file, right? So what actually happens, like the main function is this train, like this is the entry point, right? So like train basically at the end of it, what we're doing is we're saving the model, right? Like we have a model which is just like the topology and then the weights, right? And then what we're doing whenever we run train.ts is we're basically updating these weights to hopefully make the bot's neural net like stronger play strength. So like we're kind of like just kind of updating this file. But then the question is like, how do we actually use this file, right? Like, how do we plug in our bot into our game? Because even after we train this, like, it would be nice to actually like, play against our bot. Like in Connect 4, I think in like the series, I actually started off kind of like with a dummy bot that made random moves and swapped that in for a neural network which also made random moves with equal probability, and then of course filtering out illegal moves. But yeah, like that was kind of like how we began. Like we actually like built like the HTML and the CSS and like the canvas stuff, well HTML5 whatever. Like we kind of like we started like from the UI, and then we started like, and we got like a dummy bot, and then we started the actual AlphaZero, and now it's like the AlphaZero, like lots of work has been done already, and like once we kind of finish this, like we still have to integrate it to our game. So I was thinking like, you know what, I did lots of work like a few years back on bots, so maybe I can kind of like recycle a bit of that at least to integrate the bot into the game. So what I'm going to do right now is basically like just just review all the, sorry about that, review all the changes I've made from the bots. So let's get started. Initial brainstorm work on bots, remove whatever that is. Okay, so let's see here. In our run.sh file, we're just commenting out a bunch of stuff. Again, this is very old, like this is from 2021, so it's been like, it's like May right now, so it's been yeah, like 3 years. So things are probably pretty different. But anyways, so yeah, anyway, so we have run.sh. Basically I just kind of like cleared out game server and front end. I mean, we're only focusing front end, not game server and matchmaker. So okay, we're basically just kind of delegating to front ends run.sh. Then bot.css, just a bunch of CSS. It's fine. Then bot.html. So yeah, actually before we kind of like go through this chain set, let's kind of look back. And yeah, so this is like from 2019, right? 7.8 Caesar. Initial work on bots, then fix compile error, add drawer to bot, allow players to move coins against bot, add end of game pop-up with rematch and exit functionality. In progress, create min-max function, first try untested. Initial very weak bot, don't let coins reach standstill before evaluating leaf nodes. So basically when I say leaf nodes and like min-max, this is clearly just like alpha, beta, or min-max. Alpha, beta, yeah. So it's like, it's not Monte Carlo, right? It's just like very kind of basic techniques. And then, so this is that. And then let's kind of like see what we did. Like we see a CNN already. Then temp commit, I don't care about temp commits. Remove history table. History table? I forgot. Is that like transposition table? Never mind. Change local IP address. In progress, test train bot by play. I'm guessing imitation learning. Create first image stack function. Okay, so there was some image stack stuff, but that's going on. Again, we're not going to actually like repeat code. Like whatever we have in our BumperCoins bot repo, like that's gonna be the final say. I'm just gonna look at these commits to like kind of like I may even like stop a bit earlier, but at some point I'm gonna like have it detached. I'm just gonna like revert back to like some. Basically, I'm just gonna go off of one of these commits and just kind of like use that to integrate my bot to save me some work. But I'm also curious to see how far I went in the past too. So right now it looks like I'm doing like imitation learning, train bot by play, add swap players. Okay, so here's where I think I'm realizing like swaps. I'm like kind of realizing, hey, there's something called data augmentation. Create model. Again, like back then I didn't really know anything about neural networks. In fact, I probably still don't. Add create model function to create CNN. Add train model function. Add prediction helper function. So basically, I'm like kind of like doing what I'm doing in net.ts, I'm guessing. Initial version of CNN bot that's greedy and learns after game. So we have a CNN bot that plays a game. So like maybe like here's where we want to like is a promising point to like kind of like look at the diff from the start until here, like all these changes up till here. And then just like whatever the CNN bot is, like skip this train part at the end, but just like use this bot and like just like kind of plug in our own bot, right? Then initial slow forming MTCT, I think MTCS plus CNN bot. Again, like this Monte Carlo tree search or MCT, this is a typo, it should be S, I'm guessing. This is not using AlphaZero algorithm, right? Like this does not use uh these CNN bots, if I recall correctly, they're not AlphaZero CNN bots. I mean neural network bots, in that like AlphaZero, the neural net in AlphaZero kind of has two outputs, a value and a policy, right? But these CNNs only have value. Like this was before I took like like whatever Silver's like the reinforcement learning course. Revert back to I just thought that like I noticed I had minimax in like depth 3 or 4 or whatever, and like each time you increase the depth, it takes exponential. Like it's a branching factor of like 24 or whatever. So it's like way more work. So it like kind of makes the screen laggy. So I think I was using Monte Carlo tree search as a way to kind of like uh get the most bang for the buck in terms of like the time budget, right? Revert back to greedy CNN. I guess MCTS was too slow. Sprinkle in TF.tidy and TF functions. I guess that's for cleanup, like garbage, like just yeah, like manually clean up stuff. Maybe prevent out of memory errors. I don't know. Fiddle with MCTS constants, increase CNN capacity. Flip. Okay, some more. So here, I think like at some point, like I kind of realized that like the CNN stuff, like the convolutional neural network stuff, I wasn't making any progress. Like my Minimax bot was in fact actually much stronger. Like this one was basically doing random moves, and I wasn't really like it didn't seem to show any signs of intelligence, to be honest. So like you can see how like 9, 14, 15, 16, like a lot of commits in the same day, and like 17 it's like I'm just kind of like throwing stuff on the wall and hoping something sticks, but nothing is really sticking. So I can kind of like feel the desperation, like where I'm trying to like do stuff for CNN wise, and eventually I kind of like accept that, like, you know what, I'm not making any test classifications or regression. So basically, like prior to like here, everything in the CNN was only outputting like a value between like 0 or 1 or like -1 and 1 or something like that, right? But then I kind of like started to realize that, like, you know what, I need a policy output too, a classification. Like a regression is just the value output, like it just regression. But this classification is like the policy, the probability distribution, like then some fix, some then some training data stuff, random versus minimax. So I'm just like kind of like flailing about and like achieving nothing. So I do what's logical. I just give up and then wait a few years and then go back to it. So anyway, so here's kind of like a bunch of commits that we were gonna do or look over. I might not do all of them, but yeah, let's just kind of take it from the top, right? Where's my initial work? Yeah, you can see before I was working in map editor. That was the last well, it's like that's one of the second to last feature I've done in the game. The last feature is replay. These are the last two big ones, I guess. I haven't really done much work except replay. Okay, so initial brainstorm work on bot. So here's the commit I'm on, right? So okay, so now we have we create the bot.html file. We have a game over pop-up wrap, just like the current game. We have a canvas. We have some. Oh, these should be deleted. I think I just copied this from like game.cs or game.html or something. We have some sounds. Okay, yeah, fine. And then we have. Okay, I don't know what this is. Probably seems like a hack just to get some modules, or it seems like a hack. I think it's been a while, but I think I just add this line and fixed a bunch of errors. So we include a bot minified file or some JS file. Okay, so now here's bot.ts. So let's see. Yes, so you see bot worker, or worker. So basically, in Connect 4, if you remember, if you increase the number of MCTS simulations, everything basically lags. I can't really, the page is not usable. You can click, it just stalls out. So that's why the UI thread, we want the bot's computations to run in a separate thread. So that's why that's why I was using a web worker or whatever to not block the UI thread. So okay, so I see some energy stuff again, okay, I guess energy kind of works. Since we're playing against a bot, yeah, we do have to keep track of the humans player's energy, but the bot energy is irrelevant because the bot basically it has a fixed move at a fixed velocity, and we wait at least whatever 30 ticks or 60 ticks. So okay, and then we have initial game state. We have create game state. Okay, sure. We just create a game state. And then yeah, so create game state is from game state provider. So I guess that's I think we actually looked at this function. We tweaked it a bit, but anyways. And then post message for just basically testing data flow from thread to thread, just kind of testing out this message passing thing. So we have min-max bot.ts. It extends bot. Well, I don't know what bot is yet. I probably do. Number of directions is 16. I guess num_dirs was 8 for us, but 16. Direction unit vectors, min-max.get direction vectors num directions. This looks quite familiar because we have done something similar. We have cached them. I guess we're caching them here. Wait counts, play game. I remember googling how to implement min-max or some notion of look ahead in depth for AI for real-time games. And I came across this algorithm called RTMM, real-time minimax. And then they kind of did it based on the number of ticks or frames, and I did it in terms of the number of the depth. And I know their paper I read from some University of Canada or whatever, they said that time is the correct thing to use for showing progress, but I chose depth, or for pruning or to reach. Anyways, let's not get ahead of ourselves. So min-max bot, play again, lots of stubs, get direction. I did some trigger right here, obviously. I already can tell that this should be negative probably, right? Remember, anyways, get next move. Wait count for bot, wait count for human. Yeah. Because basically, I think this notion of wait count is we cannot just let everything happen at once. We have to make a move, then we have to wait a bit after the move to let the game stay advanced. And I think our wait count is 30 ticks. And then so get next move is kind of a main function, which we're basically asking about, hey bot, give me the next move. So I guess this is the function that does it for us. Min max returns a value for game from perspective of player specified by for bot. Alpha beta, yeah, this is alpha beta printing. Then get octile distance. I thought I was using Manhattan. Okay, octile. Whatever. Get coin moves. Why don't I just do just get distance, the distance from a squared dot dx dy, the whole thing square root. If we already have a square root, then oh, I guess because math.square root of 2 is a constant. Yeah, so we're not actually calling math.square root. I guess it's a little optimization. Get coin moves, okay. So I guess this is like, okay, fine. Coins are moving. Get this. Okay, sure. So these are like kind of like some lots of unimplemented stuff. And then what? Wait, what's the difference? Front-end bot min max bot TS. Oh, this bot worker.ts. Okay, so here's the actual like worker. Whatever, I'll just so I'm guessing the message that we're getting is 4, right? So we're returning like 16 or something. This file looks quite like this file, and this file look quite similar. Would I run.sh in front end? I removed TS. Okay, whatever, that's irrelevant. Basically, these are the main things right here. So we're kind of like, whatever, some build script stuff. Get current skin, get current rating. To do. Sometimes I like seeing old to do, see the progress that I made. Play bots, initial version, local page, no server communication, easy min-max search. Maybe learn and use more sophisticated techniques later after more research. Future, some way for players to code their own bots, open source the API. Let's not get ahead of ourselves. Or maybe we could, but anyways, yeah, okay, anyways, the point is that, yeah, it's time to actually use these sophisticated techniques now. What else? Lock file, let's skip that. I removed that, and then I just renamed a file. Okay, so that's the first thing. Great. Fix compile error, add drawer to bot. Actually, let's actually look at this compile error. Fix compile error. Okay, whatever, just some casting thing. Add drawer to bot. See this question mark, question mark, question mark, question mark? If we look at, you see that? The rating is question mark, question mark, question mark, question mark. That's where it comes from, right? So like, we're kind of like seeing something happen, right? So it's kind of like takes in the canvas, right? The canvas, like get element by ID, and just kind of is responsible for painting the game state onto the canvas. Restart. So we just kind of like draw the game state out, and then we, so now min-max bot worker min.js, and we're just passing it 4, and then we're receiving presumably 16, right? Okay, fine. So we kind of have the loop of like posting the message and receiving the message, and then, yeah, so it's kind of like going full cycle. We give it 4, and then we get 4 squared, 16. Okay, so this one is pretty important because I ran into this bug in replay too, where like you can't like, if you do onload function, but we already like onload already is attached to it, then by reassigning it, we're basically kind of like destroying our existing listeners. That's why we have to kind of only like additive. We only add more listeners. We don't replace them. So yeah, this just causes like certain coins to not be rendered properly. Yeah, or wins, like both. So anyways, just some like UI stuff, fixing some stuff. Add drawer to bot. Then allow players to move coins against bot. Okay, that looks important. So coin, move event list action, player bot, WebSocket, mock send, handle move event, move coin event, interval handle, handle move event. Okay, copy from move manager, no need to clamp move. Still need to clamp energy though. We're not letting the player or the bot cheat, basically. Restart. There's just some stuff that's copied from like the game, like what was this? Like bot.ts is copied from game.ts. That's all. Interval, set interval. Do I still use that or request animation frame? I forgot which one I use. I wouldn't be surprised if it's still set interval for 16.66. That's just 1 divided by 60, because 60 ticks per second. Wait, no, not 1 divided by 60. 1 divided by wait, no, hold on. 16.666 infinite. So you want 60 ticks in 1 second. So 60 ticks in 1 second. So where does 16.66 come from? So how fast do you need to like refresh? How much time should each tick take? 1 divided by 1 second divided by 1 divided by 60, right? Or no, sorry, 1000 divided by 60? 1000. Yeah, because the set interval time is in terms of milliseconds, I think. So then 1 second equals 1000 milliseconds divided by 60 to get 16.66 milliseconds, right? Yeah, 16, exactly. Yeah, just the same stuff that's the game uses. Then update, yeah, fizz update game state, energy. Yeah, just a basic update loop. How game over. Okay, fair enough. What is this called? Allow players to move. So basically, a lot of like these changes, which like have already been done in 2021, 3 years ago, I can just kind of like copy a lot of them as is. In fact, I think I'll do it off stream because like what really matters at the end of the day is training the bot. Like that's where AlphaZero comes in. This is just integrating the bot to the game. So like I already have a ton of work done, and I can just kind of review a bunch of that and then like kind of do it off stream, and then just go back to training the bot, right? So yeah, this is allow player to move coins against bot 3-5 whatever. Then this one, add end of game pop up. Let's just kind of like quickly glaze through this. Rematch, exit functionality. Okay, just some game outcome stuff. And yeah, request rematch button. Yeah, I am of the belief that you should always be able to request a rematch. And yeah, anyways, I don't like hit and runs. In progress, create min max function. Okay, here's like the actual like interesting stuff when it comes to bots. I know this is not AlphaZero or MCTS, but it's still like cool. It's a min max function. You're showing some depth. In fact, this min max, like the bot that has the best performance, is bot parentheses min max, right? Okay, so yeah, let's just kind of go. Yeah, min max bot workers, like the thing that the web worker is using, I believe. Just a bunch of hold constants. Internal. Okay, coin moves. Get direction vectors. Evaluate game state for bot. So this is like our heuristic function based on the coin health, distance to king, and oh, that's it. Okay. Game state for bot coin health. Get octal distance. So a bunch of evaluation heuristics. Then the actual heart of the thing, the function min max. I guess it was a stub and we're kind of expanding it. If the depth is search, we reach the leaf. Settle until maybe this can be an issue. Actually, When you hit the leaf node, we call evaluate at some point after letting the coins, I guess, stand still. Wait coin for coins are moving. So basically, like, wait coin, like basically, like this wait count is like once you make a move, right? And the move costs, let's say, K units of energy, then you are not allowed to make, or sorry, I guess there's some throttling. Like once you make a move for a coin or a human, like we're assuming like the bot is basically running the bot's saying, hey, I'll play this, you play that, I play this, you play that, and so forth to some depth, right? Let's look at the depth. Yes, search depth is the most important constant. I believe it's 3, and when you look at this, this video is 3, right? And once you make it 4 or you increase it, playing the bot is super laggy, right? So in theory, if we increase the depth, the bot will play better, but then it's exponential. So like that's why Minimax is not feasible, because like 3 seems to be at the time from 2021, like the heart, like my laptop. Well, I had a shitty Chromebook then, but like that's the thing, like it's exponential if we increase the search depth, right? Whereas like if 3 is not sufficient and like we kind of increase it to get something suitable, like it's not, even with alpha beta pruning, it's not like tractable to do. That's why Monte Carlo tree search is a bit better, because it can accommodate any time budget, because like it's not exponential, it's simply like kind of, yeah, I guess like linear in terms of like, it's like, do we have time? Okay, do a search. Do MCTS. Do you have a time? Do a search. Do you have time? Do a search. And keep doing searches and kind of growing the tree until we're out of time, and then we have to make a move. So that's why MCTS is a bit more, I feel, better suited to this type of real-time game. Which is why eventually I tried MCTS. Again, not in the context of AlphaZero, but just trying MCTS as a replacement for the search strategy for alpha beta. But anyways, but back to the min-max skip evaluation functions, min-max. So like if the wait coin's 0, that means we can make a move, and there are no coins moving. I don't know why I have moving, but I guess I just have it. Then we apply the move, and then we apply the move, and then we recursively call min-max. Like this function is min-max, and it kind of recursively calls min-max. Like for each of the moves, it recursively tests it out. And then again, we have to backtrack, right? We have to backtrack to like reverse the move. So this whole thing backtracks. And then the move value is greater than the best move value. So like we're basically like doing an argmax over everything. And then we get our alpha. And then this whole alpha beta pruning is, I mean, you can think of it like in terms of like, let's say like chess. If you're in a good position, or like you find a line where if you make a move that evaluates to like, let's say like 0.8, so like you're kind of like winning or whatever. I know it's not centipons, but like we're taking between -1 and 1. And like if there's a move which you can make, which your opponent has a move that can force a draw, then there's no point ever like looking in the branch where you can make like that move, which your opponent has a response that can force a draw, because that means like at best going to that line will be a draw, and at worst you'll even lose. So it's no point even considering it when you have a move that you believe, like you've seen a path where you can do better. It's like it's a way for like kind of pruning, basically aggressively pruning. So we're kind of doing alpha beta. That's why like the min max kind of passes in alpha and beta, like certain bounds too. So so yeah, we just kind of like recursively call it. And then same thing for humans, basically, like a similar case. Like, yeah, it's a similar case to that. Like this whole false and true, or true is like, no, never mind. For coins, yeah, it's a similar thing. And then we kind of like do some advancing, like, yeah, we're just kind of like advancing. Because again, like not all moves can happen once. Like we're kind of like doing some discretization here, like treating it as somewhat of a real-time game too. Like you're not going to make a move and then the next frame make another move. Like you're going to have to wait a few ticks. I guess, min ticks to advance, just to let the game unfold a bit. See a bunch of advancing stuff, and then turn this. So I guess if we haven't returns from here or here, then that means that like no one can really make a move, which means we just kind of like recursively do it, but with these kind of weight counts advanced, and that kind of notes not advancing depth, because depth is what like causes the branching factor to branch out. So I guess I kind of like generally see what I was trying to do there. It's a nice function. It's nice. Yeah, so then there's some clone game state stuff, there's some apply moves, and then there's some advanced full game state. So a lot of this stuff is like we're gonna have to rip out actually. But yeah, okay, so this is in pros create min-max function, first try untest. Okay, I'm more interested in the CNN stuff actually. Initial very weak bot. I mean, hey, let's just see. It's nice to see a nice toy example, right? Create simple game state. Move. Ask bot for a move. Doesn't this remind you of like connect 4 code? On message. It's bot for move. So you're sending worker a message to ask the bot for a move. We just ask the bot for a move, which is if the bot can execute move, like some throttling or whatever. So we're kind of keeping track of how long the bot takes to make a move. So in the callback, once we receive the move, we're going to like use this time to get a running average. How game over, we terminate the worker. I guess I realized 16 was too much and familiar 8 and directions. Fraction. Again, like for our code, like we're settled on 0.4 for this fraction. This is only going to be 0.4. I guess there I had some kind of more options, some more branching. Assume human will necessarily need at least some time between moves. 1500. So I assumed 60. I mean, I assumed 1000, like 1 second, like 60 ticks or 1 second. So I guess here we're kind of assuming everyone's really slow, I guess. Just kind of like skimming over all this. Restore the mood node. Okay, so yeah, some kind of more kind of, I guess I'm copying something somewhere. Move. So I guess like these are kind of like where the initial locations are for this thing. Okay, great. So this is like that. Don't let coins read standstill. I don't know what this is, but let's just kind of look at it. So far up to this point, like we've basically like what have we done? Like we've done like the CSS, the HTML, like we've created like the web page to play the bot. And then we kind of have like a little toy example for min-max going on, and we're just kind of like trying different things, like a history table or whatever. Like we're trying like different ways to kind of like desperately pleading with this bot to get better, trying to make improvements, but like I'm starting to get the feeling, I think like then I was kind of realizing that this is not working, that min-max and like a hard-coded function is not the way to go. So at some point I realized that like that remove history table, yeah, like we create a history table, we're removing it, and like I kind of realized that like at some point we have to like use a network, a neural net. Test. So here's where we actually create a CNN. Hey, it's discretization factor, which is I guess 3. We're doing 1, and for now. 3, 4. Yep, this is why I like this is similar to what I rederived. It's image stack stuff. So this is basically what we did in net.ts. Well, what year is this? 2019. So close to the end of 2021. Okay. CNN bot work. So first we had a min-max bot worker, right? Now we're having a CNN bot worker. Huh. Test train bot by play. Wait, but where's like the network? Like where's like the Oh, this whole thing's in progress. Okay, because I don't like see any TensorFlow being used, so I guess that's just in progress. That's okay, so these are all just like kind of okay. So this I kind of like deliberately did differently this time around. Like here we're kind of like swapping stuff in the image stacks, or I'm working like my symmetries, like my transformations are on the actual game state level. They're not on the image stack level. And I think like that just seemed more clean to me. Or I mean, I did think about it and I don't recall my anyways, whatever, we're starting fresh. All this stuff is basically like is old news. Bunch of like kind of flips, whatever. And again, these image stacks don't even consider previous game states. Like there's no prev, no historical stuff. So it's pretty poorly done anyways. Just some image stack stuff. Okay, finally, let's just skip this. Create model to create a CNN. Okay, just create model. So here, like, okay, I guess there's some max pooling batch normalization conv 2D. It looks like I did it more professionally then than I did it right now. Have all these kind of like other things too going on. Oh, I have some dropout too for generalizability. Yeah, this is actually it's actually probably a better network than I currently have, to be honest. Anyways, yeah, we finally have a model. So yeah, I did considerable work. I mean, I tried a whole bunch of things. Everything just failed and left me demoralized, which is kind of why I didn't really revisit it for many years. I mean, I got Minimax to kind of work, but I kind of realized that the depth wasn't like powerful enough. Like I couldn't really like I could get a playable bot like in this demo here, which I've already shown before. It takes me like 1 minute and 20 seconds to like beat it basically, but like it shows some signs of intelligence or it shows some understanding, but like it's too weak. And like I'm sure like increasing the depth would make it better, but again, that's exponential and like that just doesn't work. So yeah, anyways, delete that. I mean, let's skip over that and just TensorFlow. So here's where we actually create the net. So when do we use the net? Add train model. So that's what so like what I was doing then is like I was basically like playing the bot and then based on like my moves, the bot would like kind of like train off of that, as opposed to AlphaZero, which is self-play, I think. Train model function. Yeah, here's this whole transposition stuff. Like that's why like I was able to like do it so fast for Connect 4, like this whole axes transforming, because I see a validation set too, not just a model.fit like tensors validation set too. Interesting. Oh, I have a shuffle too. Wow. I guess I did it much more professionally then. Like in currently the train.cs file and BumperCoins bot in Connect 4 just does model.fit the x's and the y1s and y2s and that's it. But anyways, actually let's go back to our CNN. I want to like make a key distinction that this CNN, its output function is only 1 unit tanh. Like it's only a value. It doesn't give you a policy. There's only one. It's all sequential, right? It's TensorFlow. It's sequential. It's not like functional. It's not like it's just A B C D in a sequence. It's like where your final output is the this thing right here, the this one unit, which just spits out like given a game state, discretized, image stacked, it just gives out like, hey, like you're between like 0, you're 0.7, you're negative 0.7, you're something between, just gives you an evaluation, a value estimate. And then we use MSC for that, not softmax, or like there's no softmax, there's no classification. It's just very simple. I mean, it's like nice, but like there's only one output. There's not a policy head. There's only a value head. Anyway, so we have a CNN, and then I guess wait, do we look at this one? Prediction helper function. Outcome. It just does model.predict. That's it. After transposition. Whatever. Let's take that. Initial version. Okay, I like seeing initial version. That means like something. There's some like thing to work with. That's greedy learns after games. Quote, because it didn't do a good job learning. And what year is this? 29. Oh, it's yeah. I guess like I'm like kind of like, I guess I was working kind of hard on the bots in like September 2021, and then I eventually kind of realized that I wasn't really doing anything better than what I already did for min-max. This whole neural net stuff wasn't really playing out the way I wanted it to. Okay, so what? So we're saving our model. If we don't have the model, then we just full game state and outcomes. So much wasted work. So ultimately, the CNN bot worker, it has a function called getMove that spits out a move. Like that's like the top level, like that's what it does. Is this the callback for message? On message? Yeah, on message. So like here's like the thing where actually it calls getMove on the model, which it has loaded. Okay. And then basically I was kind of pissed off that this stuff wasn't really working the way I wanted it to, so I added MCTC, Monte Carlo tree search. Then I reverted promptly, like, yeah. Let's see how I did MCTS. I know I did it. I didn't really know much about MCTS then, so I was kind of like, I just like watched, like, I read a Wikipedia article and I watched like one thing on YouTube, but I didn't have a good grasp of it. I know I didn't do it recursively like I did it here, which is more elegant. Did it iteratively. Okay, so I have MC, instead of MC node, it's called MCT node. And then it has children, which are MCT nodes. So there is no MC edge in this. Like, the move, I guess, is the edge, MC edge, right? So the move, I'm guessing, is the move that, like, led to hitting this state. Yeah, some visits, whatever. Okay, so MCTS, high level, top level function, takes in the game state and returns a move. We create a root, okay, initialize root. Then from this number, we just kind of like, I'm guessing, so what do we do? For each of these in a loop, we get the best leaf, select it. So what's the select? Select leaf, basically like recursively goes down until like it kind of greedily, like best first, it just kind of looks at the max UCB score, and then kind of like just goes down until it finds a leaf. Like basically like in the recursive call in our Connect 4 or our existing AlphaZero recursive definition, like the recursive call like kind of does this for it. Well, I guess this uses recursion too actually, but never mind. So we're going down the stack, or like we're kind of like hitting the leaf here, and then I guess this is commented out, so we ignore it. Or I guess, okay, fine. Then if the number of leaves, if it's a 0, then we just kind of like call our neural net. We create a helper function in prior commit. We just kind of predict it, and then we back prop. So I'm guessing that just kind of goes all the way up to parents, right? So it's back prop. Do you have a parent pointer here? Yeah, so this one is a parent pointer, whereas like in mine, I see that's unnecessary, because like as a recursion like kind of unwinds, you kind of like reach the parent anyways. That's just how call stacks. That's how stacks work. Stacks have a property of reversing things as you go up, like ABC, and then CBA as you kind of like go up and down the stack. Yeah, very very unelegant code, very ugly code. So again, like you've never re-explored it, you kind of like have to do a net prediction, then you back propagate that up. Or else if you have explored it, then you expand it. What does expand do? Add children to node, but does not do a prediction back prop. Okay. You just kind of like, wait, but if you're looking at a child and we're already at the leaf, then that just feels wrong, right? Maybe, I don't know. This code does not really make sense to me. We're at the leaf, and then we're kind of like taking a child randomly, and then we're just kind of randomly like doing the same predict, like the stuff here where we're doing predict on something and then back propping up, like predict and back prop. This just feels very, this feels kind of bad. So I guess some really kind of like weird MCTS, attempt at MCTS. Okay, yes. So clearly this was terrible, and then promptly revert back to greedy CNN, then some tf.tidies, fiddle. I'm just kind of flailing around here, trying to like, what's our bug? I want to see this bug is. Continue. Number of tense units. So yeah, like a lot of stuff is kind of like happening here, but like nothing's really working. So I eventually, I know like the despair started to set in like around maybe like here. I think the despair really kicked in, but like, or even before that. So yeah, like I did a bot. I unsuccessfully tried to create a bot like which just did not work. Oh yeah, maybe I should like revisit this commit right here. Test classification instead of regression. But ultimately, it's not instead. Ultimately, the solution AlphaZero uses is like you have both of them. Like you have like an actor critic. You both have like a network that gives you a value. Like you have some value. And you have like a network that gives you like a policy. And I think AlphaGo to AlphaGo 0, like one of the things that like they realized was like you can use the same network for both the policy and the value. So you have two separate networks. Test classifications at regression. It's just gonna go down here. Yeah, so here, sigmoid. Wait, what? Okay, you know what? Forget. I'm just getting angry looking at this old code. So I think like for now, I guess what I can do off stream is I'll just kind of like go back to like kind of like where's this like initial work, this one right here, like initial brainstorm on bots. Basically like get some CSS, create like the HTML page, bot.html, have a basic web worker, but instead of min-max, it'll be like CNN bot worker. And like I'll basically and again I'll add a drawer to the bot to like basically I'll just create this, but like rather than like have minimax running or whatever, like for the bot's gray coins, we'll have we'll just have like a CNN network, just like it's basically the greedy stuff. We'll just, yeah, what we did for Connect 4, we'll just kind of have a model that just kind of, we'll have like a basic version where we can play against the bot. The bot will suck, but presumably what the training loop will look like is I will kind of like keep basically running like node train.js for like a long time. I'll like run it, and then it might take an hour a day to finish doing the training, and then I'll like copy over like this whole like model directory. I'll just kind of copy over this to the BumperCoins repository, and like play against the bot, and its play strength should hopefully increase every time I do a training thing. And this is exactly what I did for Connect 4, and it took me a week to train. So yeah, so my plan is to off stream kind of like integrate this kind of CNN bot to the game. And then, I mean, I might go over it, I might not. It's not interesting. The only interesting part is actually like the AlphaZero algorithm for training, which compiles, and like, who knows, like maybe maybe the work's done. We just have to run a whole bunch that finishes, who knows. But yeah, I think that's basically all for now, I guess. Like, basically, yeah, basically, we just, yeah, it's time to just like start training the bot, and I'll basically use existing code to I'll use existing code that I have here from 2021 to basically integrate the bot, like to basically create a web page where you can play against a bot, and that bot will basically automatically make moves using a neural net. And then that neural net will be the same one from BumperCoins bot repo that we've been working on for the past few weeks. This one right here, right? Like BumperCoins bot. And like I'll routinely copy over the model directory to like the BumperCoins, and then like train it, copy over the network, train it, copy over the weights. Like this will stay the same, but like these weights will keep changing as we train it. And then yeah, and eventually the bot will start to get good. Or not. If it doesn't, then I've just wasted like a few months, but at least I got Connect 4 working. So yeah, that's kind of like the roadmap ahead. I will do some stuff off stream to just like, and then like begin training. And I'll probably do a bunch of training off stream too, and like maybe like summarize like the changes. And like once I get like a bot that works maybe, or even if I get a failure and I just don't make any progress, I definitely want to show on stream some games of like me playing against my bot, just like I did here. Like you see this like thing right here, how I'm like playing against the bot. Like I want to like kind of stream myself playing against my own bot a bit, and like hopefully like in future, like in later as the streams go on, my bot gets stronger and stronger. So like those are my hopes. But yeah, like again, like we call TSC on train.ts and it compiles successfully. So like in theory, all we have to do is tweak some constants, see how long it takes, maybe tweak some more hyperparameters like the number of simulations, the number of self-play games, just get our training loop to be nice and tight, like, and then yeah, just start training, and then and test it out too, like train it a bit, test it out, train it, test it out. So like right now off stream, I'm gonna like create a mechanism for testing it out, and then yeah, I think I'll stop now. So basically this stream was a completely useless, like it could just be ignored because it was just like kind of me refreshing my memory over like what I've tried and like the current progress and stuff. So yeah, like this is basically a complete waste of time, but at least now I know like the next steps. So yeah,